In this problem, we're told that when the temperature T is 32 degrees Fahrenheit, the speed of sound S is 1087.5 feet per second, and we're told that for each degree increase in temperature, the speed of sound increases by 1.1 feet per second. In part A, we're asked to explain why speed is a linear function of temperature. First, note that that is telling us that we're talking about a function S of t. That means we're inputting t and we're outputting s. Just like you have f of x, function of x, we have s of t, function of t, function of temperature. They're asked to explain why is this a linear function. To be linear, we're looking for a constant rate of change. In this problem, there's a constant rate of change in the relationship between t and s. They tell us as t increases by 1, s increases by 1.1. So the constant rate of change is 1.1 divided by 1, or just 1.1. That's the slope of the function. In part B, we're asked to express s as a linear function of t. We know that t is the input variable, and it stands for temperature in Fahrenheit. We know that s is the output variable. It stands for speed of sound in feet per second. We're finding a function for s of t. We know from part A that because it has a constant rate of change, that it is a linear function. So we know the slope of this function is 1.1. We have two general equations that we work with for linear functions. We could work with the function y equals mx plus b. We use that if we know the slope and we know the y-intercept. Or we could use the point slope form, y equals m times x minus x1 plus y1. We use that form of a line if we know the slope and a point on the line. And in this case, we do know a slope and a point on the line. They've told us that the slope's 1.1, and they've told us that when the input is 32, the output is 1087.5. So we know the slope is 1.1, and we know that the point 32, 1087.5 is a point on this line. Therefore, we're ready to write the equation of this line. I'm going to use point slope form. M is 1.1, and then I use the input variable t. I subtract the x value of the point, and I add the y value of the point. So the equation of this line is s of t equals 1.1 times t minus 32 plus 1087.5. You could also rewrite that, simplify it if you like, so that it is in the form mx plus b. And if you distribute that 1.1 and simplify, you get the equation s of t equals 1.1 times t plus 1052.3. So either one of these equations is fine to use as the equation of this line. In part C, we're asked to solve this equation for t to obtain a formula for temperature. So we know that S is 1.1 T plus 1052.3. I want to solve this equation for T, so I subtract 1052.3 on both sides. And then I divide both sides by 1.1. In part D, the slope is 1 divided by 1.1. Slope is change in y divided by change in x. Or in this case, in the case of part C's formula, that's change in t divided by change in s. So now I'm going to relate that definition back to the actual value of the slope. The slope is 1 over 1.1. So in this case, change in t equals 1 divided by change in s, which equals 1.1. So they're saying when the temperature is increased by 1 degree Fahrenheit, the speed of sound will increase by 1.1 feet per second. Notice, this is exactly what they said at the beginning of the problem. This is exactly the same relationship between t and s that we found in the original function s of t.